Hello. Hello, everyone. Welcome to our talk. I realize that lunch is coming soon and it's getting prepared, but we're going to focus on the topic for this session. We'll make it through one more before lunch. Nice to see all of you here for this talk. My name is Rossen Stoyanchev, and this is Brian. I guess we'll introduce ourselves.
Yeah, sure. Hello? One. Hello? Okay. Is this on? Can you hear me?
No.
No? This one?
No, same.
Okay.
You want the microphone like you call it.
It's going to be an easy one. Hello? Yeah. Thank you. So my name is Brian. I'm working with Rossen on the Spring for GraphQL project, and I'm also working on the Spring Framework Spring Boot projects, and lately I'm also working with the Observability team, and that explains a bit the angle of the presentation today. And I'll let Rossen.
Again, my name is Rossen Stoyanchev, and I'm on the Spring Framework team. I got involved in GraphQL because the first thing you need in GraphQL is a web layer, and that's the focus of my work on the Spring Framework. So that's where it started, but of course it never ends there. There's a lot more to GraphQL. There's data as well, but fortunately working with Brian and also Mark Paluk, who is the lead of Spring Data, and we basically look after the Spring 4 GraphQL project that we're going to talk about here. I contribute on other projects as well, but yeah. So that's the agenda that we have for today. We're going to start by a quick overview, kind of an architect's perspective on GraphQL and Spring. In case you're not familiar, how many are actually using GraphQL? Let's see, a show of hands. Oh, quite a few. Okay. And how many are new to GraphQL or sort of learning about it? Okay, quite a few hands as well. So we try to strike a balance. This is part talk about new features and what's happened since the past year. But it's also partly sort of a brief overview of how to think about GraphQL from the point of view of what you already know today. We're going to use the demo as an opportunity also, again, twofold purpose. One is to demo new features, but at the same time also to learn about how requests are processed in GraphQL. Then we'll wrap up at the end with a few words about where we're going next. So most of us would be familiar with this as a typical web application. What we're used to. We're using the HTTP protocol. There are many URLs that we map to controller methods. We have annotated controllers with request mapping methods. We're steeped in the HTTP protocol, HTTP headers, cookies, content negotiation, media types, all of the things that we know about HTTP, all the richness of the HTTP protocol and what we can do on the web, all the infrastructure around it as well. With GraphQL, GraphQL takes a more data-centric approach. So it's really focused on exchanging data between client and server. There is a schema language from the start, unlike HTTP, where there is no really service definition. There are things like OpenAPI, but there is no kind of standard way to RFC for how to declare a service, and actually depending on the level of restfulness, you really probably shouldn't declare all of your REST endpoints up front. So there's a bit of a mismatch there between what you might want to do sometimes versus what's expected, whereas GraphQL is kind of more focused on a specific way of doing things and looks at exposing the data, and then we have a schema to declare what data is exposed by the server, and then there's a query language that the client can use, and that enables a lot of capabilities. It is very much focused on exchanging data, So in that sense, you can contrast with HTTP, which is capable of submitting and processing various content types. So it's kind of more broadly purposed. HTTP, there are a lot of things that you can do with that. Whereas with GraphQL, it's basically about recognizing the fact that a lot of times, mainly what we want to do when we focus on an API is to exchange data. And this is why sometimes going all the way with REST seems like, you know, a little bit taking it too far. You want to focus on actually what you want to achieve with the exchange of data. And that's an angle that GraphQL happens to handle really well. There is a sort of hierarchical, strongly typed data way of declaring the data through a schema. It's introspective. You can find out all about the types. And it's client specified, which means that when you make the query, you say exactly what parts or subsets of the data you want back, which is an important capability. It might be a little bit too small to see from the back, but this is a GraphQL user interface that a lot of you would be familiar with. It's basically on the left, it shows you details. Oh, thank you. Thank you. You see the details that are based on the schema. So the server exposes schema. The client, this GraphQL client that you get automatically out of the box, can look at the schema and then say, oh, so you can make a query called search for tracks, and these are arguments that you can pass. Then what you see in the middle is the actual query that you can send, and you have code completion there, so it's quite convenient. And then on the right, you see the results. And these are out-of-the-box capabilities with GraphQL. The fact that we have a schema means that we can build a GraphQL engine, something that on the server side is going to help to handle the requests. It can do a lot of things out of the box for any language, and there are, of course, GraphQL engines for pretty much any language, including Java. And that's going to parse the requests based on the schema. It's going to validate, so nothing can come in which is not expected, which is not defined in the schema. And it's also going to orchestrate the data fetching. So as the client specifies a hierarchical data that it wants, GraphQL, Java, or any GraphQL engine goes over that and decides what data fetcher it needs to invoke. So those are the arrows underneath. We can go to the next slide. And you can see that here more the picture with a Spring application, Spring for GraphQL, where these data fetching handlers are actually controller methods, annotated controller methods with the at schema mapping, and we have query mapping, mutation mapping, and they are the ones that are going to be responsible for bringing the data back. So GraphQL Java will step through the data that the client requested, which can be different with every request, and it's going to decide which controller methods it needs to invoke and orchestrate the whole thing. So if you think about this versus the web stack that we saw in the beginning with HTTP, the API layer is a bit at a slightly lower level. First, we have the GraphQL engine. We can go to the next slide. And then on top, we have protocols, different protocols over which we can accept these GraphQL requests. It can be over HTTP, over WebSocket. It really doesn't matter. It's typically a single endpoint that will accept all of these requests, feed them into the GraphQL engine, and then the GraphQL engine will do the initial work and then decide which data fetchers to invoke. So that really puts the API layer of what you have to do is kind of more data-focused, data-centric at a lower level below the GraphQL engine. So you have a whole layer that can do a bunch of things for your application, in validation of the inputs and so on. So that's kind of the mindset with which you begin to work. The fact that it comes over HTTP becomes less important and secondary to what really you aim to do. Right. So in terms of the Spring 4 GraphQL project, we went GA a year ago. So it's kind of in a way, fortunate and good for the conference that it coincides with the date of Spring I/O, as it did last year. Since then, so the timing of the GA release was a little interesting in the sense that it was only 6 months away from Spring Framework 6. And of course, with Spring Framework 6, we have a new baseline for Java 17, a migration to Jakarta E, lots of big changes, AOT, and native support. There's a whole observability theme, the big changes around Micrometer and building those capabilities into Spring projects. So that put us in a position where we wanted to be there to allow applications to go to that baseline. And so we focused on a 1.1 release, which includes a major Java upgrade. So it's a bit unusual, but it's a kind of compromise, I guess, because we did not make any major changes to the API. It wasn't like a new generation of the framework. It was only 6 months later. Our main focus was basically on providing a baseline for Spring Framework 6, which was still plenty of things to take care of. And then we have just this week releasing 1.2 with some new features that we're going to talk about. So for version 1.1, what are the main changes? Well, obviously we have the baseline upgrade for Spring Framework 6, Java 17, Jakarta E. That's actually not a huge deal from a GraphQL perspective because the servlet level changes, that's mostly a transport that's not visible to the application. We made sure that it works in AOT native for AOT native applications as well. And we also took the opportunity to, there's a new context propagation library. How many of you have actually heard of that, the Micrometer Context Propagation Library? Yeah, just a few hands. There was a good webinar that just went out this week, if you're curious to learn more about it. But with the changes around Micrometer, and of course in GraphQL we have interesting also requirements around being able to trace the requests for all the field fetching. So we took the opportunity to create a context propagation library to help with that. Mm-hmm. And integrate it into version 1.1. Some other features that went into 1.1, the input argument handling. So when in a GraphQL request you send some input arguments, we want to combine those into an object. That's a little bit like data binding in the web. And that object can be complex structure. It can be nested. It can have other objects that need to be instantiated that matches the input arguments the way they came from GraphQL. GraphQL also, you can define an input type with any structure. And so we try to create a Java object from that. It's not the same as JSON instantiation because in GraphQL, first of all, GraphQL Java will parse the request and it will create a map of simple values, and some of them can be enums and scalars. There's some additional work that goes into that. And then we go from that map to create the object. So we did some improvements. We originally started by taking that map, serializing it to JSON, and then back to an object. Said, okay, that seems quick and easy. But then quickly realized that you lose the GraphQL customizations to scalar values by doing that because you went through JSON round trip. Then we tried to use the data binder, and that wasn't quite the right fit either, because in data binder you're starting from request parameters and binding that onto an object, but here what we're doing is a little bit different. You're starting from a map, already has some kind of structure, and we're trying to populate an object either through constructor or setter. Anyway, this is the sort of thing that you would expect to just work, and that's exactly what we did in 1.1. It fixed a whole bunch of issues that were opened, so hopefully now it's in pretty good shape. One thing that is important, which probably if you're a GraphQL user, you would know that. When you submit arguments in GraphQL, there's an option to submit null for the argument, or you can leave out the argument completely. And that can take on a meaning, whereas in Java, all you can do is see that as a null value. There's no way to express the absence of something completely. Even if you have optional can tell you there's a value or no value, but it will not tell you was it actually a null, explicit null value or no value at all. This is more complex, just getting caught up in words. But the point is that you can imagine some use cases where you're submitting a mutation and there are maybe several parts to it, and some of them you don't submit at all. So that means we shouldn't touch that data, leave it alone, don't submit anything, versus putting an explicit null value, which then means that you actually want to update the data to replace it with a null. So that's what applications end up wanting to do with this. And so we have a way to represent that with a special type called argument value that will tell you, was it present but null, or was it not present at all?
We get actually very interesting feedback from the Kotlin community on our side. I don't know if many of you are using Spring for GraphQL with Kotlin. Raise your hand if you're using with significant amount.
Okay.
Yeah, so we're seeing that particular community being stronger on the Spring for GraphQL project. We really like it.
Yes, yeah. Although the feature is kind of language independent, if you want to do kind of optional updates, that's basically how I would summarize it. But I guess in Kotlin it's easier to express with a type. In Java I've seen optional of an optional, but we didn't go for that. Okay, next. So some improvements around controller method validation as well, to make that more streamlined and to allow group validation as well. One important feature is annotated exception handler methods, and that's in 1.2. We think that's going to work really well for applications. It allows you to handle things locally to a controller. You can handle them also across globally, a bit more to like what you might be used from Spring MVC. Pagination and sorting, we'll see that in action shortly. That's, if you have a really large result set, I guess that's an important feature. And the schema mapping inspection, that came from feedback, applications that were already using that with another framework, and trying to find that in Spring for GraphQL. It worked out fantastically, in my opinion. I think it's a really nice feature, and once you start using it on startup, it kind of tells you if something is missing, like your schema and your Java controller methods don't correspond to each other. Gives you nice feedback on startup, and you can see, so I still need to develop. But let's go into the demo to see more of that in action.
So we're gonna use the demo. This is the URL of the application. The QR code is the same. We'll share it after at the end again, the same during the Q&A section. But yeah, let's start with our application. So we are not starting from zero. We're gonna show you a bit what it's made of. So right now it's called GraphQL Music. This is an application that deals with albums and tracks.
Can you see well? Raise your hand if you can see well in the back.
With presenter mode, better? Yeah, so I'm going to zoom in, zoom out. If I forget to zoom in presenter mode, just yell. And so here it is. What we have right now, we have a Spring Boot 3.1 application just released yesterday. We're using a few dependencies, including starter GraphQL. We've chosen the WebFlux dependency, so you can use also the web with Spring MVC, but we'll talk about it a bit more. That choice being a bit structural, but not really.
We support, you can run this on MVC and WebFlux, and there's actually two things to consider. There's the web layer, and then there's also the data layer, right? Your data methods, data fetching methods can be synchronous or reactive. That's also a choice, and you can do that with both MVC and WebFlux. We support both, but we'll come back to that when we get into that level of detail about the trade-offs.
So we're storing our data in MongoDB, and we're using Actuator because we also want to have the observability feature in our application. So here we've chosen to use the Brave format and report our traces to Zipkin, but there are many other combinations that you can use. And also interesting point as well, we're using the new Docker Compose dependency, because in our case we want for developing our application we need MongoDB and Zipkin set up, and that's why we have a local compose YAML file where we are just asking for this, OpenZipkin and Mongo in our app. So that's pretty much the dependencies that we have, and now maybe time to go to the application properties just to set up a couple of things, because in our application right now we want to develop it, so we want to use the graphical UI. So by default it's not enabled because it's a conscious choice, so here we're enabling it. And as well, because we're heavily relying on looking at traces to understand what's going on with our application, because if you're familiar with GraphQL or not, as Rossen said, a lot of things happen with data and data fetchers, and depending on the request sent by the client, you don't know which data fetchers will be involved and how the data fetching will happen at runtime. So that's why tracing is really useful here, and we're going to see that. So here we're setting the probability to 1 because we want everything to be traced.
And by the way, when we say data fetchers, that's interchangeable with the controller methods, the query mapping, schema mapping, controller methods. Data fetcher is the name that GraphQL Java uses for the contract, how you register for a field to fetch the data. Our controller methods essentially become data fetchers, so that we kind of use that interchangeable if you are more used to the controller method terminology.
So the nice thing is we've started the application. I already had Docker Compose run on the side, and it's bound to the MongoDB and Zipkin instances automatically. And now we can actually go and load our graphical UI and start looking at our schema. So for this, I'm gonna go bit zoom in. Can you see this a bit, or shall we zoom in a bit more that way? Excellent. So we've got a few types. We've got an album, we've got artists, we've got lyrics, and a playlist, which is a collection of tracks, and we've got tracks, which is an actual track in an album, and a few other types that we'll discuss. As for queries, right now we can get a playlist by its ID, technical ID, or we can get all the playlists from a given user, and we can also search for track using full text search in MongoDB. So those are the contracts that we want, and those are the contracts that are currently shown in our schema. And if we look at our schema, it's pretty much the same. So the graphical UI is basically representing, including the documentation, it's representing the entire schema and everything we want. So it's just a different view of the same thing. So we worked on the schema, but so far we don't really know where we are. Like some things might have been implemented, some others not. So I guess there's might be a way to know which is which, or where do we start?
I think we have that feature in 1.2. We can use it to find out if we have all the controller methods in place, matching to the fields. And there's actually a couple of things that we're looking for. It could be that we have a data fetcher for a particular field, or if the data fetcher returns an object and then the object properties match the fields of the data that's expected, then that can work out as well transparently out of the box. So this schema inspection is going to basically check for both of those things and look through what controller methods return, compare that to the schema, and kind of continue recursively like that to figure out what you have and what you don't have. And in the GraphQL source builder that you see here, you do have to enable this, so it's not enabled out of the box. You know, maybe you're just starting, you created the whole schema, you don't want that to prevent you from starting up because you haven't written your controller methods yet. So it's up to you to get a callback here with the report in hand to decide, and in this case we're just going to log it on startup. So let's take a look, see what we have.
Yeah.
How much we've created already.
So restarting the app, we're going to see that report in action in our logs. So it's going to be pretty early in the startup sequence, and it's right there. So here we can see that we have no skip types. So some types can be skipped if we can't really analyze them. We have no unmapped registrations. Maybe we'll see about that later.
Yeah, so unmapped registration is where you may have a controller method, and that doesn't happen to match any schema field. Maybe you mistyped the method because we try to automatically match the method name to the field. So if there are mistakes like that. The first one is actually the one where we go through the schema, and for every query, for every field, we check to see, is that covered? Because if it isn't covered, what you will find out at runtime when the query is made, and if that field is a required field, then you'll get an exception, and at least you'll say, okay, something is missing. But if it is a nullable field, you'll actually just get null in the data response, and then that's just like a silent problem, essentially. So this is a sort of essential feature. And you might be wondering why GraphQL Java doesn't do that out of the box. Well, GraphQL Java doesn't have sufficient knowledge about those data fetchers. To GraphQL Java, they just look like lambdas. It doesn't know what kind of object is going to come back, so it cannot compare to what is expected to be returned. We are at a higher level, so we're in a position to make that connection and to produce this kind of report.
So this is basically your to-do list, the work that we have to do. And during startup, I'm also logging all the playlists that I'm creating at random. During startup, I took an ID, and if I actually run the query asking for a playlist and its name and the author, we're getting null as the result. This is because we don't have anything implemented at this point, and that's our job, I guess. So we're gonna go and implement that into a controller. Don't worry, I'll zoom in shortly. So we're gonna go in tracks. We have a tracks controller, but let's create a new playlist controller. Zoom in. So this is a controller. Okay, what happened? Better. So this is a controller. And now what we have on the schema, we want to get a playlist by its ID, and that's what we're going to implement. So since it's a query,
so query mapping,
and we're returning a playlist asynchronously. Playlist.
So the method name here is going to match to the field in the schema, which is the query name, basically the query field. And because it's a query mapping, that's a bit like get mapping versus request mapping. It means that the parent of that field is the query type in GraphQL Java. So that's a top-level query. And because the data is hierarchical, you can define these controller methods to match at any level. So you can go down below playlist, and playlist has albums, artists, and then you can create mappings to fetch that data separately, kind of to achieve a lazy loading effect. Or not lazy loading, but rather client-controlled loading. But at the top level, where the query is the parent type, we have the query mapping annotation for that.
So we mapped the argument with the ID, and we're using the repository that we have already to fetch that playlist. And hopefully when we restart the application, the report should be different, and we should be able to use this query. So now we're getting something different. So we don't have playlist anymore in the query, but we do have this. So I guess we have something else to take care of. But first, let's check that the query that we had.
Yeah. So what this is saying is that we now have the playlist query, but the playlist returns. Playlist itself has tracks, and our playlist object does not have a field called tracks. We're going to have to provide a data fetcher, a controller method for that. So this will kind of tell you along the way things that are missing.
So same thing, this time with a different ID. And this time, yeah, okay, so that's my playlist, and it's called Discover Weekly. And I guess we can finally start to look at some traces. So let's look at this one. So I'm going to zoom in. So one of the most requested features when we talked to GraphQL, the GraphQL Java team and GraphQL users, they were asking about flexible controller methods, a nice way to declare data fetchers, but also one of the main focus that we learned from GraphQL developers that they want to know what's happening under the covers when a request is being executed. Because unlike a REST service where you're in control of where you're fetching data, how is it being fetched, is it lazy or not, whatnot. Here, you need to be way more flexible, but at the same time, you need to understand what's happening. And here, with the observability support that we have in Spring for GraphQL and in Spring Framework, you see the entire trace. So here, at the first level, we're getting the HTTP post on the GraphQL endpoint. So that's the HTTP observability. So here, we can get data about the application, the span ID, the start time, and so on, including all the tags that were contributed by the observability feature in Spring Framework for the web layer. So including the URL, the method, and so on, if there's an exception, everything. The layer under that, same trace still, but layer under, here we are at the GraphQL query level, so the entire query being executed. So we've got the execution ID for the query, and we also have the relationship between the observations in the overall trace, and we have the operation because it could be a mutation or something else, and the actual outcome which is gathered from the entire query. And then, back to the trace, and then. Under that, we'll have all the GraphQL field fetching operations that can be nested. So one field can fetch another field and so on. So this is where the traces really shine because you don't really know at runtime what GraphQL or how GraphQL will schedule or decide to fetch and organize the fetching. So this gives you a nice view. So here it's pretty simple. We got one field being fetched. It's the playlist field.
Yeah, so the first line there is basically the HTTP transport. That's the thing that we handle transparently. Then the second line is the GraphQL Java orchestrating the handling within the GraphQL Java engine. And then anything below that is where it invokes the controller methods, the data fetchers, to actually do the work and put it back together for the response. But at the moment, it's just the playlist query mapping method. We're not fetching any related entities yet.
So you're getting the error, if there's one, the field name, including the entire path to the field. And if there are other like underlying observations because you're using a web client under the covers to fetch something else from somewhere else, this will be again nested, including up to other services across the network. So this is super powerful because you have a clear view of what happens for a given query, a given GraphQL request, and we'll leverage that again during the talk. But this time if we go, I guess, if we try to get the tracks, and what's the signature here? We want the first 5?
So these first, last, before, and after, they are part of the pagination spec, GraphQL, it's called the GraphQL connection cursor spec. It is a way to paginate through results, including cursor with every item, if you want to do that, and then specifying how many items you want, and you can go forward or backwards. And so that's what these arguments are for. Here we're asking for the first 5 from the beginning.
So we can ask if there's a next page, but we're really interested in the edges, which have nodes, and each node, that's where we have the track. So here we're be interested in the track title.
So if you're unfamiliar with the connection cursor spec, the edges, it's just a way to wrap a list. In Spring Data, we have the page or the window now. It's just a way to wrap a list so that we can associate with the actual data, we can associate a cursor, and that's really what this is about.
So each edge will have a cursor, but of course, if I run that thing, tracks will be null because we didn't do our job yet.
And it says that playlist tracks is one of the missing fields.
Yeah. So now we need to do that. And I guess I have a template for this to make it That was the tracks one. Yeah, so we'll still need to, oops, let me take that. So to do that, it's not a query anymore, it's a schema mapping. So, but this time we're not returning, what are we returning actually? We're returning some kind of collection, but paginated collection of tracks, but it's asynchronous.
Yeah, the window is a new type in Spring Data, in the latest release of Spring Data, also from this week, and that is it basically provides a way to do scrolling, what's called scrolling. So until now, Spring Data had a type called page, and that was mainly offset-based pagination, where you can refer to the index of an item in the result set, and then you can say the next 10, the next page. Window and scrolling is a bit of a more generalized way of doing that, so that it's not necessarily based on an offset or an index. If you think about a result set, if you actually in the meantime delete some items, which can happen, or add some items, now the offset index is no longer ideal because you're referring to something where the underlying number of items actually changed. With window, you also have the option to use key set based scrolling, which is essentially a way to take a few columns from the result set, the values of that, and you use those values to refer to that particular item.
Okay. And so here we're getting from a playlist to a list of tracks. We also talked in the contract about that first, last, before, after parameters that we use for pagination, and that is being materialized by a scroll subrange.
Yeah, so this is new feature in 1.2. The scroll subrange will extract the cursor information from the request. It will decode it, turn it into a Spring Data scroll position, and now we can get that information and feed it into Spring Data, so it will do it will get us the paginated data. And you can see we're returning window. We're not bothering to return a GraphQL connection object, which is actually what it needs to be in the end. So that's going to be transparently adapted under the covers.
So we wrote the query where we go, give me all the tracks with the IDs, because the playlist itself is not containing the tracks. We're just keeping references to the IDs of those tracks. And then we're asking for the count that's being asked, or 10 by default, and then the position that's being asked, or the default offset. And then we want to sort by title, because why not? And then we're asking the Mongo template to fetch the data. And this will be paginated for us. So here, the report should be clean, and it's not. Why is that?
What?
Did we make a mistake? So yeah, the
controller track. So that's the field is actually tracks, not track. Who said that? I wish I could throw a T-shirt.
So yeah, so here is the unmapped registration demo, where we see what field we were trying to do, what it's being mapped to, the controller, the method, number of args. So you know when there's a mismatch like this, you know what happened.
So you can imagine GraphQL Java calling the query mapping first, getting the playlist, and now the playlist is fed here as the parent object, and tracks is the field. So we're trying to return the tracks for the playlist, and that's a paginated type. And now it's not there anymore. That's good.
Yeah. So now let's try and get the same thing. So yeah, so we've got some data here. We've got we've got still acoustic covers and some tracks with the titles and track numbers and so on. And we've got the cursors, but maybe we're not interested in cursor for each, because what we want is to paginate. So go to the next page. And here we've got like the has next page info. So maybe we can get rid of the cursor for each node, and we can instead use like the end cursor.
Because we just need to know from where to continue for the next page.
And then, so this is a cursor, this is an opaque cursor. So we can ask like the first 5 after this.
The cursor is a base 64 encoded string, which on the server side we can reinterpret that to understand what the index was. So that's kind of part of what we take care of and there is an abstraction for it, so you can customize it. But the idea is that clients should not know what the cursor is or try to guess it, or it should be just a string that you refer to and say just the next items or items before this or after that.
So now we should have a different view. So yeah, here we've got the playlist, and here we're getting the tracks field. We can still see that as a sub field fetch. We can see that nice tree-like view here on the trace. But then we can fetch for more, I guess. Instead of just getting the title and number, I'd like to get information about the lyrics. So here the lyrics, it's just a link to a file. So here we are using a fake service that would go over the internet, fetch the lyrics file for the particular track. And here that's what we do. It's a bit longer. So here we're fetching, as you can see, we're getting the lyrics data for every track.
It's all fake data, so
Yeah.
if you look for that on Spotify, you won't find it. Springtime feeling. Well, maybe. there might be something called that.
Yeah. So here, same thing. Let's go over this. Now it should be a different view. Let's see what it looks like. So here we can see it's 2 seconds, so it's way longer. And here we can see that, okay, we still have the field, the playlist, the tracks, and under it we've got 5 fields being fetched because we have 5 songs, and we're fetching for each the lyrics. And this is the field fetching, but we don't necessarily see the service being called because we didn't add an observation for the actual service calling this. That's what we should do. But we're not going to do this right now, but what we can see right now is that on our service, we can see that we're starting to fetch the lyrics for a given song, and it roughly takes 2 seconds. So 44 to 46, it roughly takes 2 seconds, but we're doing that for every single song.
So back to, I mean, first, if you imagine what actually is happening is that GraphQL Java will fetch the playlist, and then for the playlist, it will fetch the tracks, and now it has a bunch of tracks. And then for each track, it needs to get the lyrics. And here we run into an n+1, what's known as the n+1 problem. But the fact that we're using here Webflux, well, we're using Reactor for fetching things asynchronously, means that they can be fetched in parallel, concurrently. If we were doing this in a synchronous way, GraphQL Java would go through and fetch the lyrics for each track one by one. And that means that we would get 5 times 2 seconds.
Yeah,
we would
it
get
would
that.
look more like steps.
It would draw out to the right. So the fact that it's, because GraphQL Java orchestrates the fetching of data, the concurrent handling can be quite helpful, but we're also going to take a look at how we deal with the n+1 problem in GraphQL and our support for that.
So here, instead of fetching lyrics one by one, we can also use the batch mapping annotation, which will result in an actual batch loading operation. So here...
And by doing that, we're also replacing the schema mapping method, yeah?
Yeah. So this one is not necessary anymore. So here what we do is the only thing that we need to give to GraphQL Java is some kind of map where they know from which track, which is the lyrics data that is matching. So we're given a list of tracks that GraphQL Java knows we'll need for the particular request. From that, we're collecting all the IDs that we want to fetch. We're using our lyrics service to fetch all the lyrics in one go. And once we have those, we're collecting them in a map to let GraphQL Java know this is the track ID, this is the lyrics for this track.
So you might be a bit puzzled by what's going on if you do show that previous schema mapping Control-Z a couple of times on the previous method that we replaced. So we used to have this schema mapping method where we would say, this is how you fetch the lyrics for one track. But now if it needs to fetch many tracks, it needs to call that over and over. So instead, now we remove that schema mapping method. We replace it with a batch mapping method, which says, if you actually give me a bunch of tracks, this is what the lyrics are corresponding to those tracks. And under the covers, we'll actually create a schema mapping method to still fetch one track lyrics at a time, but it's using a data loader mechanism. Won't get into that, but basically it enables you to batch load the lyrics, and that's what we're doing here.
So here we'll use same thing, and maybe not that one. Okay. Here, first 5, go. So here we're still getting 2 seconds because it's still the minimum amount of time we need to fetch several. But here we're getting like hip hop hits from Rossen. I didn't know.
Woohoo! I'm getting famous.
And here we can see the trace. So from this trace, it's more or less equivalent because we're still fetching the playlist, the tracks, and we're still given the field.
There's still a schema mapping method that will fetch the lyrics for a track, but that schema mapping method is very quick because it just essentially records the fact through the data loader that we want to load the lyrics, and then they get batch loaded. So we can probably see that in the logs much better.
Yeah.
We shouldn't see individual calls, and there it's fetch the lyrics of 5 songs. That's the batch loading essentially of all the lyrics at once. So yeah, the n+1 problem is something you run into very quickly with hierarchical data.
I think we're almost over time. We need to talk a bit about this.
Yeah, so in terms of what's next, we have, we're going to do another release in November, in 6 months. We haven't set we don't have any like very big features for that release. There are plenty of improvements. We've added a lot of features and we expect a lot of feedback, and out of that we're going to provide a lot of enhancements to the programming model. That's completely to be expected over the next 6 months. So community feedback, that's going to be very important, and we're very blessed that we've had very good feedback, and that's very, very useful to us. We are going to continue to think about what else we need to add, and there's certainly some obvious things around improvements around the WebSocket transport. There's a few other things that we can do. Maybe we could do some lightweight integration with Apollo Federation. So a few things kind of smoothing out a few corners. There isn't really anything major that we see at the moment. But yeah, that's essentially, we will also follow on any Spring Framework themes. The JDK 21 update will probably have a bit of support that's explicitly targeting Loom as well for asynchronous data fetching as an alternative to Webflux. And yeah, that's pretty much our plan at the moment. And before we get to questions, I just want to give a shout out to this brand new book that the GraphQL Java team has put out. We've worked with the GraphQL Java team from the beginning on this. They've given us essential knowledge around how things are done in GraphQL. And they've been very happy for us to provide a good way for Spring developers to build GraphQL applications, and out of that collaboration they've created this book that I think is a very good book, and we've looked at it, provided some feedback as well.
It's not just about Spring for GraphQL. It also goes back to explaining the schema, and also it's got their own perspective and experience that comes from building a GraphQL API at scale in their company, the company they're working for, and so it includes tips about designing schemas and how to evolve them, and many other things. So
it doesn't have it doesn't cover 1.2 features yet, but they will do another update. So if you get the book, you will get the updates with the book as well. It's through LeanPub, so you can expect updates to come through for that. So with that, thank you very much for coming to our talk, and yeah, we can open it up for questions. We have a few minutes. I can't tell you what's for lunch, but if it's